What's up, everybody? This is Mr. Longo, and this video is going to cover kites. Now, kites are a little bit more challenging to work with than parallelograms because they have different properties because they don't have opposite sides that are congruent. It's more about consecutive. So I like to think of kites as two isosceles triangles with the same base. Let me show you. So in a kite, you have one pair of opposite angles that are congruent. That's going to be this guy and this guy. But you have two pair of consecutive sides that are congruent. So we would have this guy congruent to that guy, and same with these two on the bottom. So if you were to draw a diagonal over here, you would see what I'm talking about. Here's an isosceles triangle on top and a different size isosceles triangle on the bottom. The diagonals are going to be perpendicular. So once we draw in the other one, all of these are going to be 90 degrees. So we have to look at our diagonals because those are going to do different things. The diagonal that goes from the congruent angle to the other congruent angle, that is going to be bisected. So that diagonal gets cut in half. The other diagonal is going to bisect the vertex angles of our isosceles triangles. So the opposite angles over here are going to bisect the opposite, this should say, angles. Okay, so those are the properties of a kite. So now we're going to go do a little bit of application with it. In the first one, it's just finding missing angles. So if you know your properties, it's pretty easy to do. First of all, usually the easiest thing to start off with is all of the angles in the center are going to be 90 degrees because diagonals are perpendicular. So angle 1 is 90. Another thing that you can do is look at any opposite angles that can be bisected. So this guy is definitely going to be 20. 3 is not 20. This is not a rhombus. So angle 4 is going to be 20 degrees because of the opposite angles that get bisected. So now you have to go back to good old-fashioned triangles add up to 180 degrees. So if we know this is 20 and we know this is 90, all we have to do is subtract both of those from 180, and we know that angle 2 is going to be 70. And finally, angle 3 is the same thing. If we know this is 90 and we know this is 40, then angle 3 is going to have to be 50. And then if you really wanted to, you can keep on going. I mean, if this is 50, this has to be 50. This is going to be 40. This is going to be 70. And the reason why those are going to be congruent is because, remember, this is an isosceles triangle on top, so those base angles are going to be congruent. All right? The second example is somewhat algebra-based. We have to find the full diagonal BD, which is extremely simple. Look. That's the short diagonal, so that's the one that's bisected. You're going to have 12 and 12, which is going to give you 24. Now the other diagonal, AC, is a little bit more challenging because we know what this part is, that's 5. We need to find this part. So the crucial piece of information there is the fact that these diagonals are perpendicular. That should remind you that you can use the Pythagorean theorem. So that would give you x squared plus 12 squared is equal to 20 squared. And then all you have to do is use your Pythagorean theorem over here, and x was going to end up giving you 16. So this guy right here is 16. So from A to C, that's going to be 21. The last part is the fact that we are looking for AB because that'll be able to determine our perimeter. Same thing, Pythagorean theorem. To do this, now we're looking for the hypotenuse. That would be 5 squared plus 12 squared is equal to c squared. And that's going to end up giving us c is equal to 13. So this part is 13. Now you have to remember what I told you earlier. We have two pair of consecutive sides that are congruent. So AD is also 13, and DC is also going to be 20. Okay? So now we just have to add all of those up. So 13 plus 13 is 26, plus 40 more is going to give us 66 for our perimeter. Okay? So that's it with kites. Again, a little bit trickier because we don't have a whole bunch of the same properties like we did with parallelograms, rectangles, rhombi, and squares. Okay? But anyway, that's it for kites. This is Longo, and I'm out. See you, bye.